Okay guys, this is one of my favorite lessons. It's called substitution because you're going to be substituting something in. That makes a lot of sense. So I want you guys to start off with chapter 7.2, page 284. It's called substitution. I'm going to start with example number 1, where we have, this is a line. By the way, you know a line when you have x's and y, just plain old x, plain old y, you got yourself a line. We have a line here in blue. We're going to have a line here, plain old x's and y's here, in red. And they're going to intersect at a point. I got to find out where it is. I could graph it. I did a little graph over there. You don't need to worry about that yet. That's what we did last lesson. But I want to be able to find it without doing a graph. So how would I do that? Well, interestingly, if I said x plus y, that's key, is equal to 5. And then I said, well, over here we have another line, y is equal to that. Well, we notice that we have x's and we have y's, and they're the same, it's two separate lines, but we're dealing with the same x's and different y's here, same y's. So what if I said, what does y over there equal? You'd be like, oh, well, y is negative 3x plus 7. Well, then isn't this negative 3x plus 7? Like, couldn't I take what this y is equal to, this, right? I got two lines, but I solved for y. Y is equal to this. Couldn't I plug that in right there? Couldn't I say, anytime you see the letter y, we know what y is because over here it tells us y is equal to negative 3x plus 7. Hey, what's y? Oh, negative 3x plus 7. Like if I got a phone call right now and said, hey, what does y equal? I know it equals negative 3x plus 7. Anytime I see a y, I'm going to plug in a negative 3x plus 7. They're the same thing. They're equal. So if y is equal to negative 3x plus 7, then look at this. By golly, there's a y. Couldn't I just write negative 3x plus 7 right there? Watch. I could write this as x plus, and instead of y equals 5, I can just replace it. I can substitute this in. If we know that y is equal to negative 3x plus 7, why don't I just substitute it into the next equation? Right? The previous, substitute it in. Make this y value negative 3x plus 7. Can you do that? Yes, you can, right? That's what's so great about this. So let's go ahead and solve this. Well, then what would x plus a negative 3x plus 7, right? So x plus a negative 3x, x take away 3x, x plus a negative 3x, that's a negative 2x, plus 7 is equal to 5. If I subtract 7 on both sides, I'm going to get negative 2x, this goes away, is equal to negative 2. And when I divide by negative 2, I'll find out that x is negative 2 divided by negative 2, that's positive 1. Divide by negative 2, I'll get negative 2 over 2, which is 1. So my x value is a 1. But if x is 1, if we know that this value is just a 1, right, this is 1. 1 plus what is 5? Well, 1 plus, this has to be a 4. 1 plus 4 is 5. Or over here, plug in the 1. Plug it in right here. Plug in a 1. Negative 3 times 1 plus 7. Well, negative 3 times 1 is just negative 3 plus 7. That's a 4. Again, it's a 4. My y value has to be 4. So if my x value is my x is equal to 1, my y is going to equal 4. That is 1 comma 4. 1 comma 4. And that's my point. 1, 4. You see my blue line's going down. Right? This ends up having a negative slope. If I were to put it in slope-intercept form, it goes down. This has a negative slope. It's going down, but it's going down even steeper. 3 times as fast going down, negative 3x. When they both go down and down, they hit right here at 1 comma negative 4. It's their point of intersection. It is the solution to our two lines of where they both have the same point. At 1, 4, if you plug in 1, 4 here, 1, 4 here, it works. If you plug in 1, 4 here, it would work. That is my point of intersection, and I used substitution to get it. Okay, we're back. Let's go ahead and get started. I want you guys to notice here on chapter 7.2, we're going to be doing example number 2, which of course is asking about substitution, and they're giving us two lines. I boxed the two lines. The first line is x plus y equals negative 4. The next line is x minus y equals 10. And the question is, do they intersect at where do they intersect? Let's use substitution. So first thing we're going to do is we either need to solve one of them for x, or we need to solve one of them for y. Traditionally, it's nice to have them in like slope-intercept form, like y equals mx plus b. So on this one in purple, you notice it says x plus y equals negative 4. Well, that's not very helpful. I want to find out, like, does y equal something or x equal something? Because I'm going to substitute it in to the next equation. So I subtracted x on both sides to put it into slope-intercept form. I minus x there, and I ended up with y equals negative x minus 4. Wait, what does y equal again? Negative x minus 4. Wait, what does y equal one more time? It's negative x minus 4. So anytime that you see the letter y, we can replace it with negative x minus 4. So, you know, you'd be walking down the street being like, hey, what's y? Oh, it's negative x minus 4. Hey, there's a y. What could I substitute in for it? I can substitute in a negative x minus 4 because that's what y is. So I'm going to plug in negative x minus 4 right there. Plug it in right here. So it'll be x minus this negative x minus 4. I'm going to plug it in. I'm going to substitute it in. So x minus this negative x minus 4 is equal to 10. So right here where y is, I'm putting a blank, and I'm going to be putting this into the blank. Put negative x minus 4 right here. Negative x minus 4. Well, look at what happens. That's a minus. Be careful. That's a negative. We've got to distribute. Distribute, distribute. So x here. A minus times a minus. A negative times a negative. That's a positive x. Right? Negative times negative. That's a negative times a negative. That's a positive. And negative times that negative 4 is a positive 4. And this equals 10. So I have two x's. 2x's plus 4 is equal to 10. If I subtract 4 and I subtract 4, I'm going to find out that goes away. 2x is equal to 6, so x is equal to 3. Well, now that I know that x is equal to 3, that's the first half of the point that I'm looking for to find out where the actual intersection is. So if I know that x equals 3, I can plug that back into either one of my equations, probably both, just to make sure. I can plug it in right here. If my x value is 3, then what does y have to be to get to y to negative 4? That is, let's go like this. If I plug in plug in a 3, then I would have 3 plus y equals negative 4. And if I subtract 3 on both sides, I'll get y is equal to negative 7. That gives me the point 3, negative 7. That's my answer. That's the intersection point. Or I could have plugged it into here. It would have been totally fine. I could plug 3 into this and subtract 3 on both sides and find out what y equals. We'll get the same negative 7. So if you notice, I graphed it right here. This purple line, that's this one. It's going down because we have a negative slope, right? I got rid of the slope-intercept form. It was a negative slope. And then in green here, if we were to graph this one, it's going up in a positive slope. And their intersection is at 3, negative 7. You could plug in 3 for x and get negative 7 out for y for both equations because that's the intersection point of your two systems.